Hi, my name is Rick Eads. I am the Product Portfolio Manager for PCI Express tools for Keysight Technologies. I also have responsibility for the transmitter test tools for our oscilloscope line. And I also serve on the PCI SIG Board of Directors and am Secretary to the PCI SIG, working in the electrical work group, the card electromechanical work group, and the serial enabling work group. Within the PCI SIG, our efforts right now are focusing on PCI Express Gen 4. And we look forward to operating PCI Express at 16 gigabits per second in the near future. One of the key challenges of measurements for NVMe, or non-volatile memory express, is in the physical layer validation. And so what we have here with our high-end oscilloscope that operates at 33 gigahertz is we're able to measure the signal quality of the transmitter. NVMe operates at speeds up to 8 gigabits per second. That means the unit interval timing is as short as 125 picoseconds. So that being that fast, PCI Express, the underlying technology for NVMe, is subject to impedance discontinuities in transmission lines. It's subject to signal quality concerns related to the packaging and the actual layout of the ICs themselves. So one of the things we want to do is to ensure that the signal quality coming from the transmitter is within the parameters specified in the PCI Express 3.0 specification. One of the implementations of NVMe is with an SSD drive, as shown here, using a connector called SFF8639, or small form factor 8639. This is a 4-lane PCI Express interface. Now this is different than the standard PCI Express interface that you would see on a server. So somehow we need to get access to these signals in order to test signal quality. One approach to that is to use this particular adapter card that converts SFF8639 to the standard CHEM form factor for PCI Express. And this allows us to use the standard PCI SIG sourced Compliance Baseboard 3.0. So by placing this in the serial cables brand adapter, we're able to then plug the adapter into a CHEM slot in the PCI SIG connector, and then we're able to use the PCI SIG's own tools or own fixturing in order to break out the NVMe signals and measure them on the oscilloscope. Another option that we have for breaking out the SFF8639 fixtures signals is using this fixture from a company called Wilder Technologies. And as you can see, we have an SFF8639 connector that's native, and we can take our SSD drive and plug it in directly. Now, this is a little bit different from the standard PCI SIG fixture plus adapter. What's nice about it is it has better signal quality. Overall, we'll measure about 30% to 40% better eyes at 8 gigabits per second. However, we need to provide power, we need to provide an external clock, and we also need to provide a mechanism externally to toggle the device through the different PCI Express compliance states. Once you have your NVMe device that has been properly fixtured and then configured to drive the PCI Express transmitter compliance pattern, the next step is to test the transmitter signal quality. And for this, we have shown here the N5393D PCI Express transmitter compliance package that runs on our DSA X Series 90,000 series oscilloscopes from Keysight Technologies. And so we'll use this application to select the speed of the signal that we're going to test. We will then select the types of tests that will run, whether they're endpoint or root complex tests, and then the software will actually go through and perform all of the necessary compliance tests in an automated fashion, resulting in an HTML formatted output that has screenshots, has max and min values, and has margin information that tells us just how much we passed or failed by when the results are presented. Once again, this is Rick Eads, and I'd like to thank you for your time as we've talked about PCI Express and NVMe technologies. For more information, please go to keysight.com and have a great day.